today's session. So just as a quick recap, I'll not execute them. I'll quickly run through what we have done. Right, time series analysis is all about the data, which is in a daily format or a weekly format or a monthly format, etc. So here we have taken the example of loading the data from Yahoo Finance, especially some financial asset prices data from Yahoo Finance, and then trying to forecast those values. Not necessary that you need to take from Yahoo Finance, only the typical prices related data can be taken from Yahoo Finance, right? The stock prices, the commodity prices, etc. They are available on Yahoo Finance. So if I really want to take them and then do some kind of a prediction of them, then probably I can take the help from Yahoo Finance, right? As you could clearly see here, we have loaded each of these libraries. We took the data right from 2015 onwards for the Bitcoin, and we have seen that the data has ranged almost from $430 in 2015 to almost $28,390 in 2023. Right, and this is how we got the graph of the plot for the closing prices. And we have got the adjusted, the monthly closing price, which is like a more smoother version, right? If I look at the volumes, even they are showing that towards the last few years, the volumes of investment in the volumes of investment in Bitcoin has actually gone up. Then we talked about computing the returns, which is the change in the price, and similarly taking the logarithm, which is more like more talking about the log returns or the geometric returns, right? And we can also look at multiple stocks if required. Instead of one single stock, if I really want the multiple stocks or the returns of the multiple stocks from Yahoo Finance, we can still get them. Then we discussed about the various properties of the asset prices and returns. So we have simply considered two columns. One is the closing price and the returns. We looked at the descriptive statistics. I'm sure all of you are comfortable with all the descriptive statistics. Then we looked at the test of normality, which is based on the Jark-Bera test or even from the Omni-Norm test. Then we looked at plotting the time series, wherein we also looked at whether there is we decomposed the time series. So the decomposition is more into the trend, the seasonality, and then the residual part, which is the random part. And we tried to plot the random, which is the residual, where we could also see that for some parts, the fluctuation, for some time period, the fluctuation is very, very minimal. Whereas in some period, especially in the later period, the volatility would have typically gone up. Right. And similarly, we could look at how the overall time series has been moving. And from here, we have computed what is called as the stationarity test. We performed a stationarity test and we were able to see that the stock prices are not stationary, whereas the stock returns, the Bitcoin prices are not stationary, whereas the Bitcoin returns are more stationary. This is one thing that we have observed. And then we have gone ahead towards the autocorrelation function and the partial autocorrelation function. to understand whether there is any kind of correlation that is existing with respect to the previous values. What we could typically see is in case of stock prices, the correlation is looking very significant, the autocorrelation. Whereas in case of returns, the correlations of different lags are looking very, very insignificant. And when it came to the partial autocorrelation, we could just see that at lag 1, the correlation is, or partial autocorrelation is almost 1. So when you have your autocorrelation to be almost very high with a very small decrease, whereas the partial autocorrelation is just significant at just lag 1, and not beyond, this could very well signify the presence of non-stationary kind of a data, right? It might very well be possible that I should take a kind of difference, take a kind of a first difference so that the data can be made stationary. So the autocorrelation being very, very high for very large number of lags, but partial autocorrelation is very significant only for the first lag, and it is not at all significant from the second lag onward. That could very well signify the presence of a non-stationarity in the data. So, which means I could very well take the first difference and try to make the data more stationary. You could also see that the partial autocorrelation of the returns is also insignificant. Now, based on this, sometimes just with a graphical way, we may or may not be able to establish whether the serial correlation is significantly present in the data or not. Just a graphical way may or may not be a sufficient approach. So what do we say is, rather than a graphical, just by looking at ACF and PACF graphs, we can also think of getting into a test. So the test is typically called as your Elgin-Box test. This Elgin-Box test has a kind of a null hypothesis saying there is no serial correlation or autocorrelation present in the data, whereas the alternate hypothesis says the serial correlation is existing. Now, this serial correlation is typically tested over some period, let's say over a 10 periods. I look at the correlations at lag 1, correlation at lag 2, so on up to the correlation at lag 10, and probably based on this I simply do a kind of a summation of the squares of all these correlations and try to look at this at around, based on the degrees of freedom, and look at it with respect to the chi-square distribution. So what we are simply saying is, if the p-value associated with this Elgin-Box test comes out to less than 0.5, I reject the null hypothesis and I go with the alternate hypothesis. Or if it is greater than or equal to 0.05, I do not reject the null hypothesis. So based on that, you can very well say whether the autocorrelation or a serial correlation was existing in the data. You could clearly see here the Elgin-Box statistic, right? You can very well look at the Elgin-Box statistic with respect to the lags 1 to 10. So at all the lags, you are finding that the statistic value is too high, right? and the p value happens to be almost 0. So p value is 0 is an indication that it is less than 0.05. I reject the null hypothesis. So my conclusion is a straightforward conclusion that the serial correlation is very much present in the closing prices. Now, serial correlation is definitely present, especially in this case, because we are talking about a non-stationary kind of a data, which is either uptrend, which is having an upward trend or a downward trend. And obviously, if, for a data which is having a kind of a trend, you would definitely find that the serial correlation would be existing in it. So here we have got that the serial correlation is existing, but generally what is suggested is you test for the serial correlation and all only when you find the data to be stationary. We have already observed using our ADF test that our data was not stationary. The price related data was not stationary. So a serial correlation may or may not give the required interpretation here. But we found the returns data to be more stationary, right? When we did the serial, when we did the stationarity test, we found that the returns data was stationary. So I can very well look at the serial correlation in the returns data. We could see that for all the 10 different lakhs, for all the 10 lakhs, we are finding that the the p value associated with this is very much greater than 0.05, indicating that the data need not be stationary. I mean, indicating that there is no serial correlation present in the data. So when there is no serial correlation, obviously a linear model, no linear model. The linear models means here we are referring to the models which are associated with the ARMA, either the AR process or the MA process or the ARMA process. None of these models are significant. None of these models will come out to be appropriate models as such, because we have not seen any kind of a serial correlation. So if some amount of serial correlation is observed in the data, then the next step would be in terms of seeing whether the AR models or the MA models or the ARMA models come in handy. So you can very well test, probably read the textual aspect or the conceptual aspects regarding these things in your CS2 course as such. And if someone is writing a CS2 exam and they require some kind of a support regarding these topics, you can very well ping me separately as well. So this is one more property that we will always check, whether there is a serial correlation present in the data or not. And once we are done with that, we are ready to model. So we are actually building our first possible model for a time series data. So that first possible model is nothing but the univariate ARIMA models. Right? So generally what happens is these ARIMA models, they are represented in two mechanisms. Right? They will be automatically determined based on the data, but the generic thing is what I'm trying to write. Some of you may be much aware of that. So generally any ARIMA model will be written in this kind of a format. If there is a seasonality in the data, then this is the full format. And if there is no seasonality in the data, then only this part is the typical representation of the ARIMA model. So here, a few things directly come into picture. The first thing that you check with is the D. D, if it is 0, it means your original data, whatever you have taken, the YT, especially let's say if I'm talking about returns, we have seen that the returns data is stationary. So the D will be taken as 0 for that kind of data. So which means I say YT is stationary. So the further modeling will happen only on YT. But if D comes out as 1, for example, in case of prices, the stock prices, the Bitcoin prices. So for them, we have seen that the prices are not stationary. So prices are not stationary means I cannot directly use them for the prediction purpose. So especially for the ARIMA model. So what is that we are doing? We will take one difference of the data, which means we'll create a new data called XT, which would be created as YT minus 1. So basically it's a simple difference between the two successive dates, the prices associated with the two successive dates, which is nothing but the change in prices. So that change in prices is coming out, let's say then that XT will be tested for stationarity. So if the XT comes out to be stationary, then it is when the D will become equal to 1. And similarly, let's say if YT is not stationary, even XT is also not stationary, then probably I would compute ZT, which is again the difference of the differences, which is the second differences. Right? I take ZT, which is the second differences, and let's say if ZT becomes stationary, then we'll say D equal to 2. So in the first step, the model will, now we'll talk about automatically determining kind of model. So the models will typically, the best model will be determined automatically. Now from that perspective, we will see, I mean, because the model will iterate against all these possibilities, what we will simply get is the D value will come out either as a 0 or a 1 or a 2. Right? And because of this reason, we should be very clear as to what we are actually talking about. Why is this D equal to 1, 2 or 0? Right? If for whatever the data set D is coming out to be 0, then we say that the original data is stationary. If D comes out to be 1, we say original data is not stationary, but the first difference of the data will become stationary. And probably if D is equal to 2, we say the data is, neither the data is stationary nor the first difference is stationary. Now we would typically look at the second difference of the data is more stationary. Right? So that is how we try to accommodate the stationarity associated with the data. Then, whichever data is stationary, either YT could be stationary or XT could be stationary or ZT could be stationary. Whichever data is stationary, we will take that data for the further modeling. We will take that data for further modeling. Now comes the P. Now let's say the best P value comes out to be some 2, right? We'll take some examples now. Let's say the best ARIMA model comes out to be ARIMA 203. ARIMA 203. Okay. So what do you write? ARIMA 203. You can very well write it as, because it is a 0, you are working with the original data, which is YT, which is working with YT. So YT will be written as some constant plus this 2 corresponds to the AR, which is the auto-regressive process, which means the dependency with the historical data. So you can very well write it as B1 times YT minus 1 plus B2 times YT minus 2. So you are referring to the same values, 2 periods of historical data. That is what you are writing here. And then the 3 here corresponds to the error term, the MA. MA is the moving average of the error terms. So we will write it as ET minus 1 plus, so ET minus 2 plus C3 times ET minus 3, and after all this, there is still an unknown part, which is the delta. Now, what are these ET minus 1? ET minus 1 is nothing but whatever was your actual value at T minus 1 minus the predicted value at T minus 1. So yesterday you would have predicted something by using your model, and the actual price was something else. The difference is what we are associating to the error. And what we are saying is that error, so you are learning from your errors, right? Which means there is whatever as the prediction error that came up yesterday, day before yesterday, and the day before that, there will be some weight that would be given to these errors as well. And based on that, you will get the current value of Y. YT would be arrived by using this kind of a equation. And obviously, this part is the predictable part, and this part will still become the unpredictable part, which is still the residue. So some part of the pattern of YT can be captured, and some other part will still remain uncaptured. So this is how we get our ARIMA model. This is how we get our ARIMA model, right? And generally what happens is when we are using these softwares, we have something like an auto ARIMA model. We have something like an auto ARIMA model. Now, this auto ARIMA model obviously takes care, right? This auto ARIMA model will try to evaluate all possible combinations of P and Q, because this is a PDQ. This it tries out the various combinations of PDQ, and based on that, it gives me the best possible model based on some error criteria or some information criteria is what we call as So again, you can very well refer to these information criteria. There are different forms of information criteria called Akaike information criteria, which is otherwise called as AIC, or there is a Bayesian information criteria called BIC, and so on. So, what is typically being looked at is the lowest values of AIC. So I would be probably looking at this particular combination of PDQ out of the various possible combination. Which particular combination of PDQ can give the lowest possible error? So that is what will typically be considered as the best fitting model. So you don't need to try all combinations, even taking of the differences, etc. also will be taken care by the auto ARIMA kind of function. Right? You just need to be comfortable in terms of interpreting those functions and trying to use it more relevant to the business. So let's look at that in case anyone has any queries on the conceptual aspects of it. First, let me spend some time on it. Otherwise, we'll simply run this on our prices and then see if there is any. What is the model? Now, this PDQ, the capitals, they are more applicable if there is a seasonality in the data. So just like the way we talked about in the normal case, here also we talk about, let's say if the capital D comes out to be 1, it's an indication that the original data is not stationary. But if I take the differences of the data, like seasonal kind of a difference of the data, right? So, YT minus YT minus 12. If I take the seasonal differences of the data, then this data looks more stationary. So this is where we get capital D equal to 1, capital D equal to 2, and so on. Right? Sometimes you may get the small d equal to 0, but the capital D equal to 1. So which means I am not taking any differences. I'm not considering this kind of a difference at all. Rather, I am considering this difference. You will get the small d as 0, but the capital D will come out to be 1. Right? Once the data becomes more stationary, now if at all I get, let's say ARIMA 2, 0, 3 and 1, 0, 0. Then it means, okay, my D and D both are 0, so I will work with the original data itself, right? And probably this is A plus, because this is 2, I say B1 times YT minus 1 plus B2 times YT minus 2 plus this is 3. C1 times ET minus 1 plus C2 times ET minus 2 plus C3 times ET minus 3 plus, now this part is 1. Probably I'll put a 1 here also. So this part is 1. So which means here D1 times, I will write this as YT minus 12. Right? If I am taking 12 months as the season. So this will become 12 months older kind of a data. And or probably if I have this as 2, then this would also become D2 times YT minus 24. So 24 months back kind of a data. And now if this is 1, probably I'm writing it as YT minus 12. I'll not use the word E1. Some probably I'll call it as F1 time, right? This one, the capital E here, ET minus 1. I'm using some notations. Now this ET minus 1 is a kind of an error that is coming out where you are talking about the actual value T minus 12 months back minus the expected value 12 months back. So that is what you can, so or you can very well say ET minus 12 directly. So I'll take it as ET minus 12, which is talking about the 12 months back, same month, 12 months back, whatever was the error. So that is how your seasonality included models come into picture. Typically, in case of stock prices and stock returns, you don't see much of predictability. So that is something that I wanted to bring it here as well. Right, in some other sales forecastings or something else, you might very well see some such kind of seasonality patterns and forecastability kind of patterns, but definitely you may not see those kind of things when it comes to the stock prices or stock returns, etc. Right. I hope the conceptual part is decently okay. So I would simply go ahead running these univariate models. So we have one interesting library called PMD Arima. PMD Arima actually does this auto Arima kind of a computation. So because it works with auto Arima kind of combination, what you could typically see is you this auto Arima, you can very well work it out. So you could see here, it will compute the auto Arima, right? Probably we can very well get you can see here, I'm starting with a p value of 0, I'm starting with a q value of 0, right? By default, it starts with the p value of 2, but we are starting off with a p value of 0. By default, it goes with a maximum value of 5, maximum d of 2, and maximum q of 5. And probably if there is a seasonality, it will go with it will start with capital P of 1, start capital Q of 1, etc. Right? And seasonality is treated as true, which means it can test for seasonality as well. Then stationarity it is treating as false, so it will test for the stationarity. If I'm setting it as true, then it will not test for the stationarity. So when I'm setting stationarity equal to false, it will test for the stationarity. It will use the Akaike information criteria to evaluate, and probably the stationarity test that it is using is the KPSS test. The seasonality test it is using is the OCSP test, right? I can go with a stepwise equal to true, or probably I can go with a stepwise equal to false, so that it will evaluate all the models. So I'll just make this change. Stepwise equal to false, right? And I can set trace equal to true, so that it will show me what all actions it has done. I'll do these two things. Okay, I'll do these two things. Stepwise equal to false. And I would also look out for trace equal to true. Okay. So I will try to go with the model summary and the model diagnostics. Let us see if the session has timed out, then we may have to run it again. Okay, the session has not timed out. Now you could see it is trying different models. It is trying all the combinations of models. Okay, so let's look at this scenario. You could see here, right now it has gone with the adjusted close. It has tried, it found first of all that the data is not stationary, the prices are not stationary. So it has first of all made them stationary by taking the first difference, yt minus 1. So based on that, it was able to see that the data is stationary. Right after the first difference, the data is stationary. So it started executing 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 2, and so on. Now finally it so came out that the best model came out to be 212 kind of a model. Why is that? You look at this 212 model, it is having an Akaike information criteria of 43. So that happens to be the least possible value out of all, right? Out of all, that happens to be the least possible value, 43,281. So that is how it was able to, it has actually executed all the models, and finally it has confirmed that 212 model is the best possible model. It has found that the 212 model is the best possible model out of all the available ones. And what you could see is it has typically given the log likelihood of that model, and the AIC is computed in our model, right? So these are the typical coefficients associated with them. And this is what is the variance of the model. So you could clearly see that you could clearly see here that the model will become 0.9 plus 0.93 times 80 minus 2. minus 0.955 times ET minus 1 plus 0.978 times ET minus 2. So that is what is the typical equation that is going to come up for the differences, and that differences you can very well add back to the last value, so that the total the prices can be computed, because here we are modeling the difference in the prices because the original data is not stationary. Are we clear on this? The model that comes out is the 2-1-2 model. And once the model is executed, you could see this is talking about the diagnostics of the residuals, right? The residual diagnostics is simply saying for the L-Jung box of the residuals, right? When we are looking at the L-Jung box test of the residuals, we are seeing that the p-value is greater than 0.05. So p-value is greater than 0.05 is an indication that there is no serial correlation that is present in the data. Right? No serial correlation is present in the data in the residuals. No serial correlation is present in the residuals, means the residuals are very well captured by our 2-1-2 model. Right? But the residuals are not normally distributed. So, which means the Jark-Bera test has rejected the null hypothesis that the residuals are not normally distributed. So, probably if the data is not normal and we have fitted a linear model, then the residuals also may not be normal. So there might be a problem with the original data itself. That original data itself might not be normal. So which means trying to fit a linear model for a data which is non-normal may not give the residuals to be normally distributed. So if they are not normally distributed, then means that it is better that I try some kind of non-linear models on the data. That's one thing that has come out as a next step. And we could also see that there is heteroscedasticity that is present in the data. This is actually called as we are talking here in terms of arch test, or sometimes we call it as a Lagrange multiplier test. So we talk about the presence of second level dependency in the data, which means at the squared level. So we generally define stationarity as mean is constant, volatility is variance is constant, and autocorrelation is only lag dependent. So, and in case of white noise, still more a sophisticated concept of stationarity, extending the stationarity, we say mean is zero, variance is constant, and autocorrelation is zero. So here I could see that the autocorrelation is zero. Mean would be zero for the residuals. But now is the variance constant or not? Now that is what can very well be tested by using this heteroscedasticity test. So if the p-value here would have been greater than 0.05, then I would have simply said that the variance would have been constant, because the null hypothesis is variance is constant with time, whereas the alternate hypothesis is the variance is not constant with time. So using that, we could have simply said that it would have been a constant variance, but because the p-value is less than 0.05 for the heteroscedasticity, I say that the variance is changing with time. So if the variance is not constant, which is not homoscedastic, then a better model to capture that variance, first level dependence in case of a serial correlation is not existing, but the second level dependence in terms of the heteroscedasticity is very much existing in the data. So this is where you can think of using some volatility modeling techniques like the Garsh models, etc., which will typically capture the conditional volatility that is present in the series, right? So these are some of the pointers that you will get after you run your model. And you could clearly see that the overall variance sigma squared that is there in the model is 7.392 into 10 to the power of 5. You could very well take the square root to get the root mean squared error of the predictability of the model. So this is what is associated with the Bitcoin prices. Now, when it comes to the Bitcoin returns, you could see here again all the possible values are being computed. And surprisingly, I got the best model, right? I got the best model as so here we got the best model as the 000 model. We have already seen that the original data itself, there is no serial correlation that is present. So when no serial correlation is present, obviously the best model would always be the 000 model. You could see here minus 9,730.77. I don't see any other value which is lesser than that. So that's where none of the models are able to outperform that. So it's a 000 model. So 000 model is nothing but yt equal to some a plus delta t. That's it. So the intercept is 0.0023, 0.0023 plus delta t. And the variance has come out to somewhere around 0.0015. I take the square root of it, I get the standard deviation. Even here we see that the serial correlation does not exist, but the returns are not, the residuals are not normally distributed, and even the heteroscedasticity is very much present in the residual. So you can capture the heteroscedasticity primarily using you can capture the heteroscedasticity primarily using the Garsh family kind of model. So that is what is the explanation that you can think of. And generally we get 4 different kinds of plots here, right? The plots generally are associated with a standardized residual. How is the residual changing with time? You could clearly see that in the initial periods, the residual was fluctuating in a very small zone. This is with respect to the price. But of late, the residual is fluctuating in a very large region. So that is a clear indication that volatility has actually increased with time. Then the residuals, we have typically plotted a histogram of the residuals. And this is a density plot. Whereas the green line shows a normal distribution plot. You could clearly see that the peak is very, very high, right? In our residual plot, peak is very high, whereas the normal distribution plot requires more of a distribution like this. So it's a clear indication that this is a very, very leptokurtic. You could see that the residuals wise, the 16.54 is the kind of a kurtosis that is associated with the residuals, right? Which shows that the residuals are very, very leptokurtic, right? And the normality is nowhere. This is a QQ plot, quintile plot, which says that if the residuals have been normally distributed, they would lie against this line, and this line would be more like a 45-degree line. The red line would be a 45-degree line, and you will find all the points well aligned to that line. So, which is not found here. And the fourth one is talking about a correlogram, which is nothing but the autocorrelation functions of the residuals at different lags. We have already seen that test-wise the autocorrelation is not present. So we are also seeing that here also the residuals are very much around the zero. Similarly, if I look at with respect to the returns also, my standardized residuals probably are seeming like they are uniformly distributed across the mean, right? Maybe the volatility is constant. That is how it is looking like. But when we have gone for our heteroscedasticity test, we saw that the volatility is not standardized across time. Even here also, you see that the normal distribution curve is very less curved, whereas the actual data is looking more and more. You are seeing that it is more and more peaked, which also means that there is some amount of outliers that are lying on either side, which is what is making it leptokurtic. Even here, with respect to normality also, we could see that some points are very much deviating from the red line, which is a clear indication that there are some points which are widely deviating from normality. So this model may not be an appropriate model. Probably there is scope for us to improve upon the model as such. So that is what a typical time series forecasting talks about. And the last step that you may want to do here, right? The last step that we may want to do here is probably look at a training data and a testing data kind of a concept, which we have done in classification models and other predictive learning models. So what we say is probably for some number of observations, right? Let's say for the last 2 years, right? I'll say for the last 2 years, which is approximately some 500 days, I will take that to be my testing data. The last 200 days, I'll take it as my testing data. Build the model for the remaining days of data that is available. And then I use, in each of the cases, I use an auto ARIMA model to really decide which model is the best, right? Probably here I will not fill the trace. The only thing is I'll say stepwise is still false so that it will experiment all the models, right? And then we will typically do the printing of the observation. Let us see. Okay, once it executes, we can just look at the statistics of what it has executed. And that is what will complete our initial basic time series analysis. I always say that this is the typical first kind of a level with respect to time series analysis. You could see here it came out as 112 that has come out as the best possible model. Right, it has come out as 112 is the best model. We have discussed about what is this 112, etc. But in all the cases, what we are seeing is even in spite of doing all these things, we are seeing that the normality is not existing and the heteroscedasticity is still existing in the data. Right, and the RMSC for the testing values is around 36,575. So that happens to be the average error in terms of our predictability. Now, when it comes to the returns, we will see the model, the best model that has come out is the 000 model itself, right? Okay, I think here, so for each of the columns, we should take. So in this case, it came out, in the second case, it so came out that the best model is a 000 kind of a model, right? And what we could typically see is the heteroscedasticity is addressed here, but the normality is still not addressed. All right. So now I can very well do a descriptive statistics on the testing data for the fiber. You could see here that the returns wise, right? We have predicted, so whatever are the actual returns, the maximum actual returns was around 14.5%. But what we could see is our predicted value is pretty much around 0. So our model was not able to capture the returns that heavily at all. So you could clearly see the prediction. You could see that this is what has been predicted. It's just the same value that has been predicted, because it is coming out as the 000 model is the best possible model. And so the value is coming out as the constant, which is 0.0031 plus delta t. So the 0.0031 is the predicted value for every period. So what could very well happen is, if our model is not emerging out as the best fitting model, we are getting a 000 model as the best fitting model, then the predictability is nothing but it's just an average value that is typically becoming the predicted value. So sometimes it might do a good job. The ARIMA kind of models can very well do a good job, but many a times they may not be. So especially in some of these problems, they may not be able to do a good job. So we'll do one thing. We will simply make one copy of this. And instead of taking the stock price, just we'll quickly run with the commodity. All else remaining the same, we'll just take the commodity price. Right? Instead of taking the Bitcoin, we'll take possibly a gold to see if there is a difference. GC equal to F, that is the code for gold. So let us try this, all else remaining the same. Just changing the gold. We'll see if there is any better model that we get. I'll just run all of them. Let it run. Okay. Because this is a daily data. So you see that there is a kind of jump, right? Probably it is giving me that, okay, there is a kind of a pattern in the price. There is an upward jump. But just if we see here, yeah, the price data is not stationary, but the return data is stationary for gold as well, right? And when we are looking at the change in the price, that is also kind of stationary. The auto correlation graph is looking more or less similar, right? So you don't see too much of a difference between the gold and this. So when you look at the univariate model, yeah, 010 appeared to be the best model for gold. And probably we found that 010 is the best model for gold price, and it looks like for the gold returns also it would be the 000 model itself. So there's not much of a difference, right? Initially I thought because of the seasonality it can capture something, but typically you can take the sales of a company, or right, typically the production of some particular crop or something, they would definitely exhibit a kind of a seasonality. Here we are not seeing specific seasonality being covered. Okay, some blank values are there, so possibly we should actually remove some of the blanks. Okay, I'll handle it because some modifications were not done to the code. We just modified the name and then left. Possibly I should have removed some of the missing values or something from the data. There would have been some missing values or something in the data. So they should have been addressed. So we'll look at that and we'll address that. Right. But I'm done with the time series analysis part. So in case anyone has any kind of questions on it, we can discuss out. Otherwise, I'll move on to our next topic. I'll share this file. Possibly, I'll share this file which is error free, right? Which is done on the Bitcoin price, and we have worked it out. So I'll share this. I'll share this file with you. and probably you can go through it and you can come back to me. Obviously, this is just the first topic, I mean, the very base area of time series analysis. So, in case you are more interested in it, you should start exploring it further by looking at the various improvisations that you can do. So, time series analysis, as I told you, this is just a univariate linear model, but you can talk about multivariate, linear, univariate, nonlinear, multivariate, nonlinear. So it can very well go beyond this to various dimensions. So it all depends on to what extent you would like to take it further. But to a large extent, whatever is mentioned as a part of your CS2 curriculum, which is again a very basic element of time series analysis, is typically taken care of here as such. So yeah, I'll pause for 2-3 minutes to see if there are any questions from anyone on this area. Otherwise, I'll move on to our next area, which is so all these are 1-2 sessions kind of topics. I have just said I would be introducing you to all these things. So the next topic that I would like to look at in this context is the web scraping part. Sometimes it might be useful for you, but of course, nowadays it is becoming more and more difficult. But nevertheless, from some sites, you can get your data quite comfortably. So that's the reason I still want to talk about it. This is something that could really help in extracting your data, but for that, you need to have a good hold on HTML, the data structure of HTML, etc. So I'll take you through some of the websites, especially Amazon, etc., where you can really try to scrap the data and try to get some insights from the data. Right. But yeah, I'll just wait for a minute or two for the queries with respect to the time series. If you want me to cover any other topics of your interest, then possibly you can let me know. I can try to take some time out to try to do the coverage of those topics. Right, I can prepare something because these are all like offbeat topics. We are just giving you an introduction to each one of them. So I'll also give you one session on image processing kind of thing. How does it work? So now I'll look at the web scraping aspect. But yeah, if you have something in mind, we can definitely look at that. Is what I wanted to communicate. ML deployment. I am really sorry, Paras. I don't come from the deployment background. I'm more of an analyst who typically works on creating the models more what you call in my laptops, and so which is more and more of a back end kind of working. I have not worked in the front end in terms of deploying an ML model, but yeah, I'll try to see if I can get someone who can actually guide you for 1 or 2 sessions on deploying ML models on any of these AWS or any of these servers. So deployment, anyhow, I have not mentioned it in my list of topics as well because I don't have that expertise of deployment. Okay. So as far as the model building, model testing, so evaluations, coming up with new algorithms. I work more on that side only, right? As I told you in the beginning itself, I am more of a domain guy who use analytics and mathematics for solving a problem. The technology wise, in terms of deploying on the various servers, etc., I haven't done so. Earlier also, when I was heading the analytics at some of the organizations, I used to have a technical team. I used to have a technical team who would typically be doing the deployment of the various models. So I did not get in much in that. Okay. Kondababu, you have missed, fair enough, but it was more of a time series analysis that we have discussed, right? Some part of that time was more spent in terms of revising what we have done in the last session, just to set the context for the today's session. So probably you can quickly go through the video, and so it is more of doing the forecasting using the ARIMA model. So that's the major theme that we have discussed in the class today. All right. Then I will start off. So probably you do the practice. In case something is not getting clear, you just let me know. I will cover it. No problem. On a one-on-one basis, we can do the coverage of these aspects. So anything majorly targeting. I mean, if you have to ask me, because I think all of you must be aware that I am a qualified actuary. I am an FIAI who work primarily in the education industry. I don't work in the actuarial domain. I work primarily in the education domain. I'm a full-time faculty in the area of finance and business analytics. And what I mean, I use all these models primarily from an education perspective, right? I build all these models. I create new algorithms. I work with the existing algorithms. Even in fact, some of you who might be writing the various exams, and if you have attended some coachings earlier, so some of the CS ones, I don't know. I did have taken 4 or 5 different kinds of coachings for different courses of the IAI. So I focus more on the education aspect, and because today in the today's world, the the data analytics, data science, machine learning, natural language processing. So I take courses in all these areas: deep learning, time series analysis. So basically, my focus is on the various models, and how do you find the solutions to various problems using different models. So that is the area that I work, and that is the area that I typically get into the training assignments as well, right? So that's the reason I did not get much into the deployment part, but definitely you should find someone who can help you out. But in future, if you are really looking for some kind of algorithm related queries or something, you can very well get back to me. All right. Okay, so now I will start working with the next topic. That is what is the web scraping. So web scraping is all about. So we have a lot of data that is lying in the websites, right? Which may not be in a tabular form, or which cannot be in a form of a CSV file which I can directly download. But it would be in a form of a HTML file, right? Most probably, or an XML file. So the HTML file is nothing but the hypertext markup language. So this is actually a kind of a language which is typically in the form of tags. I don't want to go more deeper into it, but probably it is like something like this, right? You might have a kind of a hierarchical structure like this. There is a head, and there is a kind of a body. Now within that body there could be some kind of a structure. Let's say we talk about a table which is having some ID, right? And probably let's say that table gets completed here. This table will have some rows. Each row may have some columns. So this is a typical structure in which a typical HTML file may look like. So what we say is, for some kind of websites which are following some such kind of a structure, for some kind of websites which are following some kind of a structure like this to develop, right? There are various ways in which a websites can be developed. So only where we have a websites which follow this kind of a structure. Of course, you may find a good number of websites with this structure, but some of them have a very complex structure that identifying this kind of a structure to write our program to extract the data that we really want is a slightly complex process. So from some websites, extracting the data is very easy, whereas for some websites, extracting may be a very difficult exercise as well. But that is where probably the advancing into the various areas of web scraping also would come in more handy. Now, why are we typically looking at web scraping? As you are already aware, that sometimes the data is not directly available. Probably I can think of, let's say, if I'm looking at a list of reviews for a particular product of Amazon, right? They are not available in a downloadable form, but definitely they are available on the website of Amazon. All the reviews are available on the website of Amazon. For let's say a mobile phone, a smartphone of Apple. So I have a good number of reviews that are there. So I want to download all the reviews and probably I want to analyze those reviews. Now in those cases, probably the better solution is to scrape the web. So you can very well, we always talk about GIGO in the entire analytics world. We talk about GIGO, garbage in, garbage out. So obviously we require good quality data, right? And obviously if our inputs, whatever is the input data that we are giving to our model, if that is an erroneous input, obviously our output also is going to be erroneous. So our insights may not be that useful kind of insights. So anything that is there on the third parties websites like Amazon reviews, right? So some of these things where you don't want to just do a copy paste, you want to directly scrape it from there so that you get even the latest data also at regular intervals of time. So if at all I want to get the data from those websites, I just give the name of the URL and I'll show you how do we do that. So obviously right now my focus is only on the very basic structure and how do I scrape the data if a site is following this basic structure. So obviously this is also a part of unstructured data, just like a text mining. First of all, we require text to do a text mining. So probably here I'm creating such a kind of a text data. In some cases, we may even convert that text data into a tabular data as well. But right now I am talking about retrieving the unstructured data from a website. And probably in some cases, we convert it into a structured format, right? So I'll show you probably the name of the product or probably the price of the product. We extract only those values and then we will try to save them, right? So you can go into Amazon and based on the product, you can really look at the product details and you can very well go into the reviews of the product and something. Now, the question is, what kind of sites, from what kind of sites can I scrap the data, right? So generally, when people are doing web scraping, right, this particular web scraping also increases the web traffic because there are some kind of libraries. Probably I'm not going to deal with that. There is some library called Selenium where the scraping is done based on a method of dynamically clicking on the various links also. Selenium is a kind of a library which actually helps us in getting the content by clicking on the various links of the site. So it's like a more dynamic stuff. Whereas when we are referring to, let's say, a beautiful soup kind of library, we are purely doing it by giving a particular page, and based on that page, we are extracting some information that is there on the page, right? So some kind of web scraping can actually cause the server. It can actually increase the load on the server. Where is that web scraping? Okay, I think somewhere got omitted or what? All right. So when you are doing a web scraping using Selenium or some other such kind of libraries, then what we are saying is the load on the server can typically increase, and because of that, the server might typically go down. So in those cases, some kind of websites, they do not allow people to scrape them. We can test whether it is scrapable or not. So we can test whether it is scrapable or not. Not all websites are scrapable. So we can actually look at, there is something called robots.txt. So this is a file that you can very well look at. So which is like, you can, let's say if I'm having a website like actuariesindia.org. Let's say I'm having one such kind of a website called actuariesindia.org and you can put robots.text. It can actually tell you uh, it will actually tell you whether you can scrape the data from this website or not. So after that, you can very well go ahead. So if you are able to, let's say, we look at actuariesindia.org. Yeah. So is this legal? Anything that is there on the public website is nothing but it's a public domain. So anything that is present on the public domain. So this is like again a kind of a debate that can typically go on, right? But if they have put something in a public domain, website is like a public domain. So you can so you are not getting into the ones that they are not visible, right? You cannot you cannot log in into someone else's account and all. Whatever is visible, let's say on a Wikipedia site, there is so much of information that is available on Wikipedia. The only thing is it is not downloadable in a CSV format, right? Or probably in Amazon, we have lots of products and lots of reviews that are there. Probably you can copy paste all of them and then you can do your analysis because it's available in the public domain. Now, all we are saying is the scrapping is typically an automated way of copying something that is there in the public domain. You are not getting into their databases. You are not looking at getting into their servers to typically get the data. The only thing is you are simply automating the copy paste kind of a mechanism. So I don't see there is any big issue in doing it, right? If the company, let's say, if a simple thing, if the company has displayed the names and if the company has displayed the names and the phone numbers of the people, if the company has displayed the names and the phone numbers of the people in a website publicly, all we are saying is I'm accumulating all of them and putting it in a kind of a CSV and doing some analysis on the top of it. It's as good as, let's say, if the ESPN crickinfo.com, just that the IPL has started, wanted to use that example. Let's say the ESPN crickinfo.com publishes the statistics of various players at different points in time. I want to utilize that data to do some kind of analysis, my own analysis on that data. Obviously, I can still get that data, probably quoting them that the data has been pulled from ESPN Cricinfo. I can very well get the data because it is available in public domain. Probably I may not sell that data to someone else, then that becomes more illegal. But I'm really not sure, Paras. I mean, there are some discussions that go around it. But when we are simply looking at data which is available in the public domain, I don't see any specific reason why I cannot access it and utilize it for doing some further analysis on it. So there are, I mean, probably people are putting, let's say we are talking about the social media posts, tweets. So there are so many papers that are published based on the data that has been scrapped from various sources. So if they would have been in very famous internationally reputed journals as well. So I'm really not sure about the legality of it, but probably within your organization you can very well check because I don't see any specific reason that it cannot be legal. Yes, the legality will come into picture when I'm intruding into the privacy of their servers and etc. But here, as long as I'm not getting into the servers, as I'm just making an unstructured data, I don't see any problem in it. right? But if there is something I suggest that you can refer me to that as well, because I mean I'm not able to make out, right? Sometimes people keep asking, but I don't see any reason why it cannot be legal. All right. Then so if at all, let's say you go into let's say a simple google.com or actuariesindia.com, and probably you do a robots.txt. You see, there are so many things that it is disallowing. So Google does not allow. So wherever there is a disallow, so all those things you cannot scrape at all from that site. So Google does not allow scraping for many of the links. You see, many of the sublinks, Google does not allow scraping them. So, but some of them it is allowing, right? You could clearly see here. So calendar, it is allowing you to scrape, right? Profiles, photos, these are some things that it is allowing you to scrape. Accounts is allowing something. So some of the areas it is allowing to scrape, but majority of the areas it is not. So any website can make itself unscrapable also. Let's look at Actuaries India website, whether it is scrapable or not. You see here, it is allowing all, but now you see the profiles and all, they are disallowed. Right? Probably something relating to the login, user, password, they are all disallowed, means they cannot be scrapped, they cannot be searched by the search engines. There are so many things. Whereas it only allows you something that is there as a part of the core and something that is there as a part of the profile. So these are the only, I mean, whatever are there, the images and all that are there as a part of the profiles, but the actual entire profiles is something that it is not allowing. So you may not be able to scrap too much of information from this particular website. So wherever there is a possibility of scrapping, then what about Amazon India? So Amazon, but you could see that it allows a few of them. So wherever it allows, you can very well get access to that. Okay. Okay, let's get back. So, so if you want to collect information from those particular subdomains, you can very well get. Right? If you want to get information for a specific subdomain, then you can very well get. Otherwise, you would not be able to scrap. And The typical thing that you can also see is the user agent, right? So you can also see, I mean, whether the a particular user can really get in terms of scraping it or not. So it's more like a bot web scraping. Now again, the legality is something that we can still discuss on it. So, but it's simply like a bot where we are browsing different pages of the site, and whatever are the important aspects of that pages we require, we are simply getting them. Okay. So basically, every time you are going into the next page, etc. The request goes to the server, and the data that is there in the server comes out to you in the form of response. And it can typically extract the content and show it to you. So as I told you, not every site is scrapable, right? But sometimes where do we require it? Probably someone has written some kind of blogs. You really want to assess what is the quality of those blogs, what is the mood of those blogs, what are the various topics that are being discussed in those blogs, or probably some kind of tweets. You want to analyze something about the tweets. So wherever such kind of information which is not directly downloadable, we can do it using the scraping. So typically, if you talk about the typical steps that you will get in when you are doing the scrapping, so you inspect the website, whether it is scrapable or not. You look at which sections of that website are scrapable and which sections are not. Right? You access the URL using your code. We will talk about how to access that particular URL. And once you are able to access it, you will be able have you have typically this is happening on the URL. You are not hitting the URL directly on your browser, but your program will be hitting that particular URL. So you are able to access the URL. That's the second step, which means all the contents of that website will get accessible. Now, whatever is the content that you want, let's say I want the list of all the players who are listed on the ESPN website for the today's match between Sunrisers Hyderabad and Rajasthan Royals. I really want the list of all the players who are listed in the playing 11, whatever it is, right? I may go to that website and I may copy it, but in some cases, I may want my program to do that. So whatever is the content that is downloaded, that I want to download, right? I would typically I would convert this content into a kind of a tabular format or into some kind of a structured format. And whatever is the information that is useless, knock it out. Whatever is the useful information, retain. So basically, you are making it more and more into a structured format. And probably if you want multiple such kind of pages, the same information, sometimes what happens is _1 or 2, 3. So the page numbers would typically come in your URL saying as page 1, page 2, page 3. So put it as a variable and put it into a loop. you will get all yours. So I have put a couple of examples of that kind also here in our workout. Of course, I have looked at some of the sites that could be scrapable, and I have taken, of course, from the Amazon also we can do this kind of activity. So I'll showcase to you how we can typically do these kind of things in Amazon and probably any other simple sites as well. So if the but the only drawback or major drawback, I say, I don't say only drawback, because at some point I was able to easily scrape the data from tourism websites like what is that, TripAdvisor, and probably some feedback websites like mouthchat.com, etc. But nowadays it is becoming slightly more difficult to scrape the data from those websites. Earlier, I scraped that data, used it as a part of my some of my research projects, etc. But nowadays it is becoming more difficult. So whenever you are able to successfully write your code to scrape, better scrape the data, convert it into a CSV file and save it, right? Because as time processes, the companies may change their front end, so the entire HTML structure might change, and because of that, the scrapping the data will become more and more difficult. So if the website changes its front end structure, then obviously sometimes it becomes more difficult. You have to alter your code and things like that. There are various other ways. Probably you can talk of something called XPath and doing some kind of scraping based on the path, overall path, etc. But again, these are all slightly more difficult aspects, and we may not want to get into all those things to start with. So probably it's almost 6:45. But let me see if I can just quickly get started with this. Probably in our tomorrow's class, we will try more and more details into it. There are a couple of libraries that we really require. One is request. The request is actually a kind of a request that you are making to the URL. So you will give a specific URL and you will try to extract the data that is there from that specific URL. So request is always an important function that would make a request. So it's as good as it connects to that particular URL, it executes that particular URL, not in your browser, but internally. It sends a request to the web server for that particular URL, and it gets whatever is the data that is present in that particular URL. So that is what is being executed by this library called request. And we have an important library called BS4. So this BS4 actually contains a very important module or a function called beautiful soup. So there is a function called beautiful soup, right? So you see here, there is a beautiful soup. This function typically does a lot of activities on the data that is extracted from the web. Right, on the HTML file that is extracted, a lot of functionalities are being provided. So once the data is, for doing a better scraping of the data, this particular function called beautiful soup will come in more handy. So these are the two libraries or the packages that I'm going to install. I am again just simply referring to the importing these two packages as well. I think I may have to run this as well. All right. Now, this is not required. So now I want to use the IMDb database, right? The movies database. And I have this chart top. So let us see. Let's click on this database on this website. So probably this is this database, right? So this is the simple website, and I could see that these are the various top 250 movies, which is there in this kind of a format, right? You could see that the data has been updated over the last, right? We have 2020, 2022 movie is there in between, right? We also have 2020. There's a 2023 movie also that has made an entry. So this list keeps changing, right? Spider-Man was of 2021. There is an Indian movie, Jai Bhim, of 2021. Like that. Okay. So which means the list is typically changing every year. Now, so I want a kind of an access to this, right? So that is where I would typically want my program to run this, right? I want my program to run this. So I say that this is the source. I just give the, so basically what could happen if I copy paste, then this would not be dynamic. But if I run it in this manner, then I would get a kind of a dynamic listing. Now I will say source is get whatever is the data that is there in this particular website. Now, if you really follow the variables, the source is actually containing the response. So if you give a request, the response will come. And whenever the response is at 200, it is like it's a valid response, right? Probably you get sometimes 404 error, you get some such kind of things, right? So they are all like errors, but if you are getting at 200, then it is generally like a valid response. Now you are typically collecting the whatever the text that has come from that source. We are sending it to the beautiful soup, and we have to parse it. What is parsing? As I told you, the HTML has a specific structure, right? We have displayed the HTML structure earlier. So basically, it will identify which values are there as a part of which structure. So which ones are there as a part of table, which are there as a part of row, which are there as a part of columns. All these things, they are clearly segregated. That is what is being done as a part of this step called beautiful soup when you are using beautiful soup. Now, if you really look at this beautiful soup here, you could see here the entire set. You could see here the whole structured way of the HTML is being represented here. It's in a complete which what are the links, which ones are the links. Now let's say in a particular page I want to extract all the links that are there, right? I can simply use this and I can typically say wherever the link tag is there, you get me all the value. So whichever are the links that are there on that page, I can simply extract them. Now here, okay, I think we have to get into, now I'll show in this page, right? How do I really access each of these things? So any page, if you have to put into the code, any page, you do the inspecting of that particular page, right? We'll go step by step. Probably, I think not today. We'll go into the scrapping part, right? By looking at this, how do I incorporate this into my code? We will just explore it probably tomorrow. So if you really look at clicking here, you can very well capture every element. You see here, it is capturable. Every element is typically capturable, right? So what you generally do is we will typically capture this entire table, right? We'll talk about how do I capture this entire table, and based on that, how do I typically capture each and every observation. So here we say I will find this T body. Okay, right now let's leave it. We will take it up in our tomorrow's session. Tomorrow's session is more about this web scraping, right? Sometimes it would really help you, especially when the data is there in some other sites and it's not available for a direct download. You can very well use this kind of a mechanism as such, right? A lot of companies give students these kind of exercises to work on also. So I definitely see that there is a benefit that the companies can get by doing this exercise. All right. So I'll stop this here. Tomorrow it is from 7 to 9. Only weekends I cannot take in the evenings, late evening, right? But in the weekdays, we'll have it from 7 to 9 itself. I think we have two more sessions to go. So tomorrow and one more, I'll plan it on Wednesday or something, unless you have some other requirement to work upon. Okay. Yeah. Thanks a lot, everyone.